This question is taken from the ENGAA 2020 Section 1 paper, and it is question 27. So we read, a coil of wire with side lengths 30 cm and 20 cm is pivoted about an axle. The axle passes through the middle of the 30 cm side length. Part of the coil is between the poles of a U-shaped magnet, with the pole length being 4 cm. So we have a diagram here. The coil current is 0.6 amps, the magnetic field is 0.05 Tesla, and the coil has 50 turns of wire in it. What is the moment about the axle in Newton centimeters produced by the magnetic force acting on the coil? So immediately when we think of a magnetic force and then also a moment, at the same time we should think force is VIL times the number of turns as well, because it'll experience a stronger force due to these 50 turns, and then also times the perpendicular distance. So putting all these numbers in together to get the moment using F equals VIL and then times in by the distance, we have 50 for the turns times magnetic field times current times the actual length in the poles, so 4 centimeters. The 20 centimeters, as you can tell, is a red herring in this because we only care about the part that's between the poles, or where the current is actually acting in between the magnetic field. And then times the 15 centimeters because the axle is halfway between. So notice how I converted the 4 centimeters into 0.04 but kept the 15 centimeters as this, just because the question asked us for the answer in Newton centimeters. So watch out for those unit conversions. So we have 2.5 from this part times 0.6 times 0.6 from 15 times 0.04. So this is 2.5 times 3/5, which will be 1.5 times another 3/5. We get 0.9 Newton centimeters. So whenever dealing with these questions, especially with magnetic forces, think of BIL, and then the number of turns as well should be incorporated into this. And then for a moment we simply multiply by the force from the axle or pivot. Points for stumbling include which lengths to use. So this is where the tricks may come in if you're not careful. So it's only the part that's within the circuit or within the poles that we care about that's experiencing the magnetic field. So 4 centimeters, not the 20 centimeters. So all in all, we got a moment of 0.9 Newton centimeters.